So friends, here is the next question. What is skew or skewness? Explain left-right skew distribution with example. So what is skewness? In a layman terms, we have to say that it is a measure of the asymmetry of the probability distribution. Not so layman term, but in a term, right? So probability distribution can be anything, right? It can be this, it can be a standard normal Gaussian distribution, it can be a uniform distribution like this, it can be like this, right? There could be various type. But what is symmetric? This is symmetric. This looks symmetric. This doesn't look symmetric. It has a tail type thing, right? This is called tail, this area. Okay, this particular thing has a tail towards the left side, right? So these are not symmetric. If we try to see across this particular line, the center line, it doesn't look that symmetric, right? So this is the whole point of, this is what we are calling skew, right? Let's see over here that what is skew and first. So as I was saying that this is the visual example, right? This is a standard normal distribution, perfect symmetrical across. If it is perfect symmetry, then your mean, median and mode all will lie at the same point. And that happens in case of Gaussian distribution, right? Perfect Gaussian distribution. If it is negatively skewed, why we call it negatively skewed? Because it is tailing towards the left side, right? So it can be called left skew or it can be called negative skew, right? On the y-axis, you have the frequency distribution and x-axis, you have the x variable, right? So this is the, in case of negative skew, what will happen? Your mode, median and mean, how it will lie? Obviously, the mean will lie towards the further west, right? And your median will be after that, the 50th percentile, and mode anyway will be the highest point. Why mean will deviate from the highest point? Because mean is nothing but the average. So it has to divide this particular area into two parts, right? If you see the positively skewed, right, there are a lot of data which is towards the right side, okay? And if it is going towards the right side, in that particular case, you can see, friends, the mode will always be the highest point, median will be the 50th percentile, mean will be towards the right of the graph. Why it will be towards the right? Because there are a lot of data on the right side, and mean has to cover those also, right? So mode spread out mean, median and mode greater the skew. So another thing is, if there is a greater difference between mode, median and mean, and especially between mean and mode, greater the skew will be. Obviously, it makes intuitive sense that if my mean is further away from mode, that means there is a greater asymmetry in the distribution. If my mean, median and mode all lies at the same point, that means there is a very strong symmetry, right? Again, positive or right skew is mean greater than median greater than mode. Negative or left skew, mode greater than median, greater than mean. Okay. Now this is the way how you calculate it. If you have to calculate a skew, now there is a term called Pearson's coefficient of a skew, and this is how it is calculated. So you calculate first the difference between the mean and the mode, and you divide by the standard deviation. I am using S because it is a sample, and X bar because we are dealing with the sample. Using median, you can also calculate it's 3 x bar minus median by S. We can calculate in both the ways. Difference between mean and mode and difference between mean and median. How it is? Because empirically somebody has found out that mean minus mode is 3 times mean minus median. You plug this over here, this formula, that means it becomes 3 mean minus mode, median, right? Why two? The question is why two ways of calculating, using mode and then median. Okay, so historically people have figured out that this is much easier, right? And sometimes mode can be less predictive in the sense that mode, sometime in a smaller data set, you will notice that the mode is not very reliable, okay, in a smaller data set. That's why we try to go towards the second formula using median. Why divide by a standard deviation? Again, this is the standardization, right? Because it's a coefficient. If you have to compare two data set, that hey, what is the skew of first data distribution versus second data distribution? It has to be standardized. And what is the best way of standardizing? Dividing by standard deviation, right? Why 3 times? I think I already told this is an empirically driven thing. Why do we care about skew or skewness? Why do we do that? So many statistical machine models assume the variables or the residual to be normally distributed, right? So we assume normal distribution. If there is skewness, it cannot be. So if there is a skew, what do? Should we leave it? No. What we do is we do a feature engineering. We do some log transformation, we do polynomial transformation, and try to make it pseudo-normal or not. To certain extent, normality needs to be arrived over there. Okay. Now the question is left or right skewed. Number of COVID infections over time in India. Do you think it is right skewed or left skewed? Number of COVID infections over time in India. Is it left skewed or right skewed? Think for a moment and tell me. Okay. Now, if you notice the graph of how COVID has started with a bang, and how it is going. This is like the first wave. This is like second wave, and it keeps on up and down maybe, right? But it keeps on going. It has not gone away. So where it is, this looks like a right-tailed, right? Right-tailed. And when it is right-tailed, that means it is right or positive skewed, right? This data is right or positive skewed. Okay. Now the second question is, what was the second question? Salary of employees in your company. Think about it. The salary of employee in your company, whether it will be left skewed or right skewed. Again, let's try to draw. Where the majority of the employees will be. The majority of the employees will be there, but there will be some senior executives, right? Your CEO, CFO, CMO, the senior executives, right? And it will keep on going towards the right, where finally somewhere ended that hopefully this is the salary of the CEO, right? And it will end over here, correct? But where the majority of the people will work, the majority of the people will be over here. Again, this data is positive or right skewed data. Okay. Now what was the third scenario? Distribution of scores on easy exam. What is the distribution of a score? Suppose you're in a part of a class and teacher has given you a very easy exam. What do you think will happen? What do you think will happen? Think for a moment. Okay. Most of the people will score poorly or good. There will be very small number of people who will still do poorly over here, right? But the majority of the people will do good in this test, right? With a cap of 100 maybe. This is if it's a 100-mark test, then this is 100, right? This is 0. Very few people will still do like 30 and 40 and something like that. But the majority of the people will lie in this particular region, right? So this is one of the cases, and this is a very important interview question. This is one of the cases where this data is negative or right skewed, right? So if somebody asks you in an interview question that, hey, tell me about a scenario where the data is left or negative skewed, you can tell this particular example. Okay.